In this video, we will discuss calculations using the normal distribution and StatCrunch. Let's find some definitions and terminology to begin. First of all, look at the graphic on the screen. This is a histogram of a normal distribution, which means that we have a central peak, and then the frequency on each side of that peak is the same. If we draw a smooth curve through the top of the bars, we will get our bell-shaped curve or normal distribution curve. In general, a normal distribution can have any number of means and standard deviations. However, in order to perform calculations using our normal standard curve, we have to normalize or standardize the data, which means that we have to have a mean of 0 and a standard deviation of 1. Using the normal table, you can find the number of standard deviations that you are from the mean, which is called the z-score, or the z-value, which is a probability, percentage, or area under the curve. In StatCrunch, you're going to select Stat, Calculator, and Normal, which means you're using the normal calculator. And you will see the menu to the left. There are 4 boxes in that menu in which you can enter data in addition to changing the inequality symbol. And the rectangles shown on this graphic tell you what can go in each one of those areas. The procedure that we're going to use is we're going to start by reading the problem and underlining the important information. Then we're going to draw a normal curve that represents the information that we are given. We're going to analyze what we're given and what we're asked to find, and then we're going to go into StatCrunch and perform the calculation. We will have 3 options in StatCrunch to perform these calculations. We can have a less than, a greater than, and a between data values. And we're going to go through each one of these as an example. So on example 1, the problem reads, IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. We're asked to find the percentage of IQ scores that are less than 115. We start this by underlining the pertinent information, which would be the mean of 100, standard deviation of 15, and percentage less than 115. And we sketched the normal curve in this graphic. And to do that, you start by placing the mean of 100 at the demarcation for the highest point. Then, to get the standard deviation values to the right, you would add the standard deviation of 15 to each of the previous values. And on the left side of 100, you would subtract 15 from each one of the previous standard deviation values. Once you've done that, you're going to find 115, and you're going to then shade to the left of that, which means we're going to do less than. In looking at what we're given on this problem, we're given the mean, the standard deviation, and asked to find a percentage that is less than. So if we proceed to StatCrunch, and remember StatCrunch is located under Question Help in the homework, You'll choose Stat, Calculator, and Normal, and you will get the screen shown to the left. You will enter 100 for the mean, 15 for the standard deviation. The default for the inequality symbol is less than, which is what we are using. So then we can enter 115 into the next box. At this point, you would click Compute, and you would get the results that 84.13% of the IQ scores will be less than 115. One thing to do is to check the graphic of the normal curve that you get in StatCrunch against what you drew previously. Our second example is going to be a percentage greater than. And the problem states that we have a normal distribution of heights of adult males with a mean of 174 centimeters and a standard deviation of 7 centimeters. We're asked to find the percentage of heights greater than 180 centimeters. If we underline the pertinent information, we would underline mean of 174, standard deviation of 7, percentage, greater than, and 180. So our graphic of the normal curve is given to the left, and we do it exactly the same way that we did the previous one. We start with 174 at the peak. We add the standard deviation of 7 to the right to get the standard deviation delineation marks. We subtract 7 to the left. Then we would locate 180 and we would shade the area to the right. So then we proceed to StatCrunch, and once we have the menu shown, you would enter 174 for the mean, 7 for the standard deviation. We would need to change our inequality to greater than, and then enter the data value of 180 and click Compute. Notice this graphic matches what we did earlier, and also the percentage of adult males more than 180 centimeters tall is 19.57. Our third example is a percentage between two data values. And the problem states that the SAT math scores are normally distributed with a mean of 621 and a standard deviation of 98. We want to find the percentage of scores between 550 and 650. So the pertinent information that we would underline would be mean of 621, standard deviation of 98, percentage between 550 and 650. So our graphic for the curve is shown to the left, and we do it exactly the same way, except that once we get the standard deviation marks written, we would find approximately where 550 and 650 are, and we would shade the area under the curve between those two. In StatCrunch, this one is a little bit different because we are asked to find the area between. So the first thing we're going to do is at the top of the screen, we're going to click on the Between option. Once we do that, it's pretty straightforward to enter 621 for the mean, 98 for the standard deviation, and then the smaller data value will go in the first box and the larger will go in the second box. When we click compute, we will note that the percentage of students that have an SAT score for math between 550 and 650 is 38.20. The last topic that we want to discuss relative to the normal distribution is the central limit theorem. Note that the histogram for the top population distribution is not normally distributed. We don't have that single peak with frequencies on each side the same. In order to use what we have done previously in StatCrunch, we need to have a normal distribution. However, if we know that we can find sample sizes large enough, we can use the normal distribution. So what we would do is we would take many samples of a fixed size, and we would find that the higher the number of samples, the closer we are to a normal distribution, even if the original population distribution was not normal. In StatCrunch, we'll use the population mean that we're given, but the standard deviation will become sigma, which is the population standard deviation we're given, divided by the square root of the sample size. And you will need to do this calculation before you go into StatCrunch. Let's look at a problem represented by this. The head width must be considered when designing motorcycle helmets. Research has shown that the mean width for males is 6 inches with a standard deviation of 1 inch. If one male is randomly selected, what is the likelihood that this head width will be less than 6.2 inches? The second part of this problem is if the company selects many random samples of 100 males each, what is the likelihood that the head width will be less than 6.2 inches? Now, in looking at this problem, in the first part, we're going to go ahead and use StatCrunch with a mean of 6 inches, a standard deviation of 1 inch, and our x value is going to be 6.2. And we're doing a less than. And the result shown is that we would have 57.93% of the population whose head width is less than 6.2 inches. Now, this means that we manufacture helmets at that demarcation, and we're probably not going to cover most of the population. For the second part of the problem, since we have many random samples of size 100, we could use the central limit theorem. So before we go into StatCrunch, we're going to calculate the standard deviation, which is sigma, and they told us that was 1, divided by the square root of our sample size, and that's 100. So our new standard deviation is going to be 0.1, and that's what we will enter into StatCrunch. So if we look at our menu, our mean is 6, our standard deviation is 0.1, our x value is 6.2, and when we click compute, we get 97.72%. This would definitely cover a larger percentage of the male width.